All of the others who had not paid attention, it is for them now. So what we studied in our last class is this: the universal law of gravitation, two bodies of mass m1 and m2 separated by a distance r, the force of attraction between them. Now when I say the force of attraction, this is the force with which this one is pulling this, and same as this one is pulling this. Okay, the force is the same, right? And the force is given by g m1 m2 by r square. After putting the value, g is said to be 6.7 10 to the power minus 11. Have you understood this much? This was a recap. So today what we do, out of the two bodies, we freeze earth as one of the body, freeze one of the body as earth, and take another body which is exactly equal to 1 kg mass for simplicity, right? And put that 1 kg mass on the surface of the earth. So now what is the distance of separation? The radius of the earth. You may say, sir, it should also be the radius of the body. Doesn't make any sense, because the radius of the body would be very, very small. The same example where what I gave here is that if you spend lakhs in a wedding and you say I saved 20 rupees in an auto fare, it does not mean anything. Okay, so it is, that's why I put this symbol approximately. It's approximately the radius of the earth. Nobody is going to make you do these calculations. It's just so that you understand. Now let us find the force of attraction. We always say earth attracts the body, but in actual the body is also attracting earth. We will see that part later. Let's first quantify the force. So if you quantify the force, you put the figure 6.7 10 to the power minus 11, and the mass of the earth is 6 into 10 to the power 24 kgs into 1 kg divided by the radius of the earth, which is 6,400 kilometers. So I first converted into meters and then I squared it up. It comes 9.81 Newton. Understood? So from here, can I write one line that earth attracts a body of mass 1 kg kept on its surface by a force equal to 9.81 Newton. Have you understood this? You need to remember this figure. Huh? This will be very handy for us going forward. Nobody is worried about the calculation. This slowly, if you study physics later on, this will come automatically to you. How do you get this 9.81? And let me also not deprive that particular 1 kg body of its right. We are only favoring the earth out here. So we can also say a 1 kg body kept on the surface of earth attracts earth by a force equal to 9.81 Newton. No one can deny this fact. Clear? But the question then comes, why is the ball always coming towards the earth, but the earth is not going towards the ball? That's the question. Yeah. Mathematically they are correct, right? Mathematically they are correct. Have you understood till this much? Yes. Okay. Let's say, nail biting again. Okay, let's now see this part of the diagram. Sanvi, Neha, both in page with me now. Okay, now let's see this part. You know what is my problem now? My problem is, if these two forces are equal, why do we always see the result biased in case of the earth, that the earth is always pulling the body and the body is not pulling the earth? That is my area of concern or my question. Okay, so once you have written this, we attack that next part.
RE is the
radius of the earth, which is actually the distance of separation between, and this can be between you and earth also. Sorry, you replace this by your mass. Say you are 47 kg, 50 kg, 54. You replace with your mass, then you will find at what force earth is attracting you. We can find that also. And the distance of separation in your case also will be RE, because you are standing on the surface of the earth. Clear? So shall we now attack our answer to that? Okay. Okay. Hey, either.
Thank you.
Yeah. You didn't hear the pencil falling, by the way? Oh, great. You should never give accolades and credits to yourself. That let a third party and the world decide. New watch? Achha, very good. Sambhal ke rakho. Hey, can I go ahead? My hands are itching now to explain this. Okay. So earth attracts. Now let's see this part of the story. What is happening here? Okay, so there is a body out here. The mass of the body is how much? 1 kg. And say on this side we are having earth, right? We are not drawing the earth anymore. What is the force it is feeling, beta? 9.81 Newton. Right? Yeah. Let's go back to chapter number 2. Force experienced by a body is given as mass into acceleration. We will say mass of the body into acceleration of the body. Got it? Mass of the body into acceleration of the body. So 9.81 Newton is equal to 1 into AB, or AB is equal to, AB is equal to 9.81 meters upon second square. This is the acceleration felt by the 1 kg mass. No, that will come later, a little bit more later. This is the acceleration felt by the mass. See, when I am pulling you with 9.81 Newton, go back to Newton's law. If there is a F net, there has to be an A net. The A net felt by it is this. And it is in which direction? Towards the direction of the earth. This is what happens in normal world. This is the force with which Shaurya will be falling on earth. Anyone will fall. This is happens. And that's why we are standing on earth. We are not rising up. Had it been moon or somewhere else, I would have been now jumping and jumping in this way. But I am standing on earth because somebody is pulling me down. Okay? Let's see the story here. Here the story is different. So let me write this with the blue pen. The story here is that there is a body of 1 kg mass and there is earth here. This is the story. Alright? Earth is being also pulled by 9.81 Newton. This is the story out here. So let's find what is the force that the earth is experiencing. Mass of the earth into acceleration that has been caused on the earth. Right? Now let us see what is the acceleration on the earth. 9.81 divided by 6 into 10 to the power 24 meters per second square. I will not calculate it. Your intelligence should be sufficient enough to understand that this is negligible. You are dividing 9 with how much? 6 into 10 to the power 24. So the acceleration felt by the earth is very, 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 very less. That's why earth is not moving towards the ball. Ball moves. See, you should see it like this. This is 6. This is also 6. This is 6 into 1 into 6. This is 6 into 1. Did you understand? See, this is, imagine that this is a 6 unit force. How to get a 6? You can get a 6 as 1 into 6. The acceleration is very high. Here also it is 6. But here the acceleration is 6 into 1. The acceleration is less. Force वही है. Neha and Sanvi, have you understood? So that's why you feel that the earth always attracts the ball and the ball is not attracted, but the ball is also attracting the earth. And what justifies this? Newton's third law. We can put it in gravitation also. Newton's third law says when a body exerts a force on another body, the other body exerts an equal and opposite force on the first body. That's why we are getting, if this fellow dear earth is pulling him by 9.81, body is also pulling dear earth by 9.81. Newton's third law is valid. However, Newton's third law also gives us Newton's second law, that is force equal to mass into acceleration, clarifies why we observe goat, sheep, human being going towards the earth and earth not coming. Imagine you, Sarthak walking and earth walking behind him. And then they shoot that Telugu song, I want to follow you. It comes like that. Right? It doesn't happen. Is it clear? You can note down now. No one is going to ask you any math. You will get some very baseline mathematics out here. Baseline problems. Well, they'll tell you, take this as 6 into 10 to the power minus 11. 11th physics hard, 10th is numerical oriented more. You've got two topics, electricity and light. Both are numerical oriented. Light so हाँ 8 का बहुत सारा position 8 के साथ match करेगा. In fact, maybe the first 4-5 classes you all will feel bored in light. It is everything that is 8th grade. And then suddenly the numerical part starts up. But you have more numericals in electricity. But they are straight, problems oriented. But when you come to 11 and 12, it's a completely different ball game. So have you understood this part? इसको लिख लीजिए, ठीक है? कॉमर्स में अप्लाइड मैथमेटिक्स पढ़ोगे, देन कॉमर्स में पढ़ोगे आप बुक कीपिंग, बिजनेस ऑर्गेनाइजेशन, then there's nothing hard. You should be good in mathematics also. Nothing is hard as long as if your two things marry, my interest and my ability to work hard. Suppose, like say, indulging something with electronics is my passion. If you wake me up at 12 o'clock and say do this, I will never say no. But if you ask me at 12 o'clock, go there and do something else, I'll not do. So it has to be your liking. That's why they say lucky are the people who are doing job in their area of interest. They do something which they like and they get paid for that. But majority of the people do a job to sustain the living, because you can't do without a job, but you don't like the job. Tabhi to office jane se again I'll see that kharus boss, again this, again that, and that's when stress starts building up, because you don't have likability. Today, suppose you are waiting for the office to end up at 5:30, you want to go and start your car and go back home, but you love to play guitar, and at 5:25 I come to your table, Aparna, can you show me how to play this chord? You will just open your backpack and keep it, and you say no, tighten it this way, and you start forgetting that at 5:30 you were eager to go to the back. But if I tell you at 5:25, Aparna, this is that Excel file, the data is not flowing, can we do tomorrow? That will be your answer. So that should not be interest. ठीक है, हो गया बच्चा? This one, can I do Rabi here? This one, Rabi.
You can do the other one.
The other one we will keep, because everything will hover around the earth now. So we have now understood two things based on this. I'm just writing. We did some experiments out here. We found that the force is considerable. F means, okay, the gravitational force. No, it's not any other force. It's considerable when masses are large. That we did the other day. Masses are large. We did a experimental calculation with Earth and Moon. You remember? Masses are large. Then the next is opposite. Force is negligible for bodies of less mass. This was what? This was that boy and girl wala example. Aditya ka jo dekha rahe the. It was that example. The force is negligible. It was coming 10 to the power minus something. Then the third thing that we saw today, that force is effective, okay, in terms of movement for body with higher mass. They can give you true or false questions, so apply these logic. The force is effective in terms of movement, not for body, towards body with higher mass. Did you understand what I wrote the third one? Towards body with higher mass means, like Earth, the movement will happen towards the body with higher mass. For a heavy versus light mass system. Exactly the experiment that you saw right now. You have a heavy and a light mass. In this case, movement will always be seen towards the heavier mass. Clear? Okay, third one, what I have written, the force is effective in terms of movement towards body with heavier mass for a heavy light mass system. If you have a heavy light mass system, the force is always effective in terms of movement towards the heavier mass, not towards the lighter mass. Did you get it? Want me to repeat once again, Sanvi? Okay. Force is effective in terms of movement towards body with higher mass. Force is effective in terms of movement towards body with higher mass. Everything came towards the earth. If you would have had something which is substantially heavier than the earth will move towards it. Okay? Again, Aparna. The best medicine for this is what you know. Just chop bitter gourd and just and then she can't bite it. If she likes bitter, she can bite. Oh, that I did with the other fellow, Lavia. Lavia, I just took pliers one day.
Why?
After that, he never he used to anytime bite. Okay, with higher mass. Have you understood this? And the fourth one, Newton's third law. Newton's third law holds true for a two-body system in terms of universal gravitational force of attraction. In terms of universal gravitational force of attraction. Have you understood? Newton's third law holds true now. Zoe, your much awaited 9.81 we will now come. Okay, chale, ho gaya? Newton's third law holds true for a two-body system in terms of universal gravitational force of attraction. If you have understood, you should be able to write all on your own. Remember these when you ask, because this question chapter, they don't give you calculation, they will give you more of true or false type questions come a lot. Can I do a little bit of rubby-dubby? Okay, let us rub from this side. Yes, Neha Sanvi, can I rub this portion? Don't nod head. I can't see you.
Yes, sir.
My speakers and computers are SAP betrayers. So, okay. आज की आवाज खांसी बंद होके इकप है. Something is there. Your bias is garbar actually. In computer we have something called bias. Your bias has defect. Okay. We come to a new topic now which is known as free fall. Very interesting topic. Free fall. Free fall. Humpty Dumpty and a free fall. Free fall. Let's say we have the tower of our B tower. This is our B tower, and we have a naughty kid out here. Okay, this kid takes out a tennis ball and just drops it. Okay, drops it means you have to understand it from physics perspective, not throw. Throw means there is a force with which I have. He just drops it. The other English that I can say is releases it. And the interpretation from chapter number 1, we will say initial velocity is 0. Okay, initial velocity is 0. Everything will merge now. Right, he drops it. And where has he dropped it? He has dropped it on Mother Earth. This is Mother Earth. Right, he has just dropped it or released it. Now Mother Earth will be pulling this body towards its center, universal law of gravitation we just saw. Now it will be pulled towards its center, right? Now that is a force of attraction. Say this, there's a force with which the body will be pulled. F is the force with which Earth will attract or pull the body towards its center. Have you understood? Towards its center. We will no more say that the ball pulls the earth, because we have found that as per clause number 3, for a light and a heavy mass system, there is no point in looking at the other one. There will be hardly any acceleration, right? So this is a force. So if this be a force, this force can also be expressed as mass into acceleration. Mass means mass of the body, and acceleration means acceleration experienced by the body, right? replace the ball and put Shaurya here and just release him. Even he will be attracted towards the earth, right? So he will also have an acceleration, right? Then you put a goat out here and you release the goat, goat will also have an acceleration. Now, I told you, come to first chapter, first day's talk. The force between two bodies on the universe is called the universal force of gravitation, and I told you shift your paradigm, and if you are making one body as earth, I call it as force of gravity because I'm thinking from the earth's perspective. So can I write this as, this is the force of gravity of earth, and this force of gravity of earth is typically associated with a free fall, when it's a free fall, because if you throw something, then you are not being justified in calling it force of gravity. Exact for, see, I was like this. Do I make tasty rasgullas? If I'm making tasty rasgullas, that person without any bribery, any YouTube ad or any content should automatically come to my shop. If I'm pushing that person or bribing that person, then actually he might be coming to me, but it's not measure of my actual attraction of my rasgullas. So when we call the force of gravity of earth, it should always be a free fall. Free fall means no force acting on you while you just started to fall. Okay? It's called the force of gravity of earth. So when you look at force of gravity of earth, that is the force with which earth pulls everybody towards its center, then this acceleration gets a new name and we replace it by g and we call it acceleration due to gravity. Acceleration due to gravity. Got it? Acceleration due to gravity. Not any other acceleration. It will be known as acceleration due to gravity. Clear? When you look at the force of gravity of earth, then that force experienced by a body is the product of mass of the body and the acceleration. That is called acceleration. Now your next question should be, sir, if you have termed it and coined it as acceleration due to gravity, do you mean to say that this is something unique, constant for everyone? I say yes, this is constant, and your heart doesn't want to agree because you put here a table tennis ball. You mean to say, sir, the same acceleration will be for table tennis ball as I put a goat or I put Shaurya? I said yes, it's the same. That we will prove now. That why have I coined it a name? Are you getting it? This acceleration will be same for everybody. We'll just see that. How much this acceleration comes up. We gave it a name. Sanvi, have you understood? We gave it a name called acceleration due to gravity. So you should first ask, sir, does it have a value? I said, yes, it has a value. Is it a universally? No, not universally. Is it a constant when we are in earth? Because we are talking about earth. Yes, it's a constant in earth. You mean to say, sir, it doesn't depend on what type of body I am dropping? No, it doesn't depend. That is the next episode that we will go see. Once you, it will not depend on any of the body. ठीक है? We'll see that. ये part मिटा दूं? Very good. If you are ready to understand why it will not depend, we can do it now. Have you understood so far? Greek Latin तो नहीं हो रहा है? Okay. ओए हुआ तेरा? अभी आके बोलेगा सर आई एम राइटिंग. लिख लिया? ठीक है, चले आगे. So we'll see why this force will be unique. Right? The force will be unique. Let's see that. Let's look at once again Newton's law of gravitation and find what is the force with which is existing between the earth and the ball. Is given by the relation, and let's say the mass of the ball is m. We are taking it as m. Understood? So it can be goat, anything. We give it as g me m divided by re square. Now you can again say, sir, we are quite above the earth. Why are you still taking? Still we can take it as re. Still this distance will not matter. It will be what, some feet. What is the height of titanium in front of 6,400 kilometers here? Doesn't make any difference. Okay. So if you see from Hyderabad to Delhi by road will be around 12 to 1300 kilometers. You go once, you almost go 5 times between Hyderabad Delhi, and in front of that, what is titanium? Nothing. So you can still ignore this and assume as if it is on the surface of the earth, right? This is the force. Now, what is the force experienced? The same force is experienced by that particular mass. Can I write it as the mass of the body? Let's say mb into an acceleration that this body feels, okay? An acceleration that this body feels, and that acceleration we have seen is g. That acceleration is g. When Earth attracts any other body, Earth attracts any other body, we call this as g. Have you understood? These two forces are same, right? These two forces are same. Say this be A and let this be B. They are same. So the left hand sides go away. I just equate the right hand sides. G ME MB divided by, and now you are studying good advanced physics you are studying, is equal to MB into G. Agreed? Right? If that be the case, can I not strike out MB? Yeah. So that's it. That was what I was waiting for. G is equal to G ME divided by RE square. In fact, G is now independent of the mass of any body. Is there any mass of the body in this expression? Do you see mass of the body? No. So you drop Shaurya, goat, butterfly, or table tennis ball, or ambassador car, the G value has nothing to do with this mass, because this figure is no more appearing in the expression. Let's solve this. If you try to solve this, it will be G 6.7 into 10 to the power minus 11 multiplied by 6 into 10 to the power 24 divided by 6,400 into 10 to the power 3, that's meters square, and you go back and find the same value, which is 9.81 meter. No, this is acceleration per second square. That was Newton, means a body of mass 1 kg experiences a force of 9.81 Newton. And it will be clear. Now we'll get that also clear. What did you find in the other case? If the body is of mass 1 kg, you found that the force is 9.81 Newton. So what should be the acceleration? 9.81. That's what you got here. Otherwise, how do you satisfy this equation? A body of mass 1 kg experiences a force of 9.81. So what is the acceleration? 9.81. Have you understood? So this figure now should go down your throat till the time you study physics. G, the acceleration due to gravity of Earth, has a value of 9.81 meters per second square. We take it constant, but we actually don't have the right to take it constant. Why? Because ma'am explained that in geography, the Earth is not round but flattened at the poles. And this is the equator. Agreed? So don't you think that RE at the equator is greater than RE at the poles? Yes or no? Little bit. So if you go to the and then take this expression. What is the expression of G? G is equal to G ME divided by RE square. Now if you are at the poles, your RP is what? Your RP is small. So G value increases. And if you are at the equator, the RE value is more. So the G value comes down. So where should be the force of attraction of a body more? Wherever the value of G is more. Where is the G more? The G is always more at the equator. Yeah. Equator may poles. The G is always more at poles. So if I keep, say, Shaurya here, his force of attraction, force on Shaurya at pole, and if you keep Shaurya here, okay, then force of attraction on Shaurya on equator, this fellow is actually higher, because in this case the G is higher. Force is mass into gravity. Half class, right? Thank you. Understood this much?
Yes.
We'll do a small recap. Yeah, yes.
Sir, I can understand the entire.
Okay. This part you understood, or should I go ahead?
That was the part I didn't understand.
Okay, you didn't understand. Did you understand till this drawing part?
Yeah.
Okay. Did you understand that G is acceleration due to gravity when we said that whenever Earth is pulling any body towards itself, the body experiences a force, and as per Newton's law of gravitation, the force is always the product of mass and an acceleration, right? Newton's law of motion, second law, says that. So that force is given as mass into acceleration experienced by the body. Now, since the force is created by Earth, we give a new name to the acceleration. We call it acceleration due to gravity. It's a नया नाम दे दिया. And that holds good whenever it's the force of gravity of Earth. That holds good whenever it's a case of free fall or a drop, not when you throw something. Is this much clear? Then my question that was that since I have given this a specific name called acceleration due to gravity, my next question is, sir, is it dependent on the type of body that is being attracted by the Earth? Suppose I have a goat, I have a sheep, or I have a table tennis ball, or I have whatever in the world you can think of. Will this acceleration change? First of all, our mind starts thinking, yeah, it should change. How can everybody have the same acceleration? But we say no, it's a universal figure and it has got a universal value associated with it, which is 9.81 meter per second square, which we just calculated, but I'll explain you once again. So I say this is a constant. This is a constant as long as you are on Earth. So your query is, how do you prove it is constant? So I say, look, the force of attraction between Earth and this particular ball can always be given by this expression called G, mass of Earth, mass of ball, divided, or you take this as mass of body, any body it can be, right from a car to a rhino, divided by the radius of the Earth. Is this one clear? This is from the law of gravitation. The same force is experienced by this body or acts on this body. So force is also the product of mass and acceleration. So I write that the force is can be quantified as mass of the body into acceleration. Now, since the force belongs to Earth, I change the terminology of acceleration and I call it G, where G is acceleration due to gravity. Have you understood these two steps? Tell me.
Yeah.
Both the forces are same, A and B. Their left hand side is same, so their right hand side should be same. So I equate the right hand sides. MB strikes off MB. And that was what I was looking for. I want to say that the G is now having an expression which does not have any mass of the body term in it at all, which tells me that G has no impact on what type of body you are dropping. Whether you drop a ball or you drop a nail or you drop a sack of rice, nothing, because the value of G is capital G, mass of the Earth, divided by square of the radius of Earth. Do you see any expression for mass of the body? No, you don't see. And if you don't see, that means the mass of the body plays no role in ascertaining the value of G, which means our previous talk was correct, that acceleration due to gravity is something unique for Earth. Got it? And if that be unique, I should be able to associate a value with it. And I now punch the values for G, which is 6.7 10 to the power minus 11, mass of the Earth 6 into 10 to the power 24, divided by 6410 to the power 3 whole square. And I get a value which is 9.81 meter per second square. And that's what you need to remember, that whenever anything falls on the Earth under free fall, the Earth pulls it with a force. I don't know what is the force. Force will be dependent on the mass. But the acceleration that will be on that body will always be 9.81 meter per second square, be it a rhinoceros or be it a feather from a duck. Clear? And then since the expression has got a square of the Earth as its denominator out here, I now started to put the concept of Earth where we say that the Earth is not round but flattened at the poles, which means the radius at the poles are shorter than the radius at the equator. So that's also a question which comes. They may ask you, where does a body experience more force? A body experiences more force wherever the acceleration will be more. So look at the acceleration. The denominator factor increases for equator, so the G factor reduces for equator. The denominator factor shortens for the pole, so the G factor
it's directly proportional.
More, inversely proportional. Inversely proportional. Understood? So if you are sitting here, Neha, you experience a force, since your radius is less, you experience a force which is much more. And if you are at Ecuador, Indonesia, Ghana, then you experience a force which is less, slightly less, as compared to when you are at, say, something over Norway, what you will feel. Got it? You know what type of countries these are called? Scandinavian countries. Norway, Sweden, Finland. Greenland is uninhabited. So the countries that we have: Alaska, some portion of Alaska, Sweden, Denmark, then Finland, Iceland, Norway. What was the capital of Finland? Helsinki. Okay. समझ में आया? And this is the concept of free fall. And once concept of free fall comes, now we will again try to marry whether the first chapter marries with this topic or not. What is the name of the first chapter?
Uniformly accelerated motion in a straight line.
Straight line. All the bodies which undergo free fall, do they have an acceleration? Yes. Is the acceleration constant? Yes. So uniformly accelerated motion, honored. And the free fall is always a straight line. So the first chapter equations will be valid here also. Not only when you drop it, but if you sit down and fire a bullet upwards vertically straight, then also it is experiencing a uniform acceleration. Acceleration is acting downwards, that's a different story, but it's going straight, uniformly accelerated. So that for that it will be a uniformly retarded motion. That's why the body goes and stops at some place. Concept socho? G is always acting downwards. Which G? This G. If you fire a bullet upwards or you throw a ball upwards, the ball, you have thrown it with the force. Good. What about the acceleration? Initially, your force is more, your acceleration is more. And Earth has a constant acceleration. So as the ball starts going up and up, your force reduces because your force dies down. Your force has to do work against what? Against the gravity. So your force dies down, your acceleration dies down. So which acceleration is now being more powerful? G is being more far. And G is which direction? Downward direction. So it starts countering your upward flight till you reach a portion where your velocity will be 0. After that, you have no more force. Ball starts coming down. If you and me play, say, hand-to-hand combat and you start pushing me and my strength is more than you, initially what I'll do, I'll try to overcome you. You won't be able to push me any further. Then we reach the center line. Now all your strength is down. After that, it's my win over you. That's what happens in this case. Okay? If you have done, we'll see that example cases now. Yes, Neha and Sanvi, clear or not? Sanvi, some clouding? No clouding. Okay. Chale, Ravis? Let's rub. So, what did we study today? We started our discussion to see force between two bodies in which we took one body substantially less in mass over the other. So, what was the example? We took Earth and a 1 kg body, and we found that in such cases, the force of attraction exists between both bodies, but however, movement will be observed only in the body with lighter mass. Okay, because the acceleration is more in that case. That's one thing we saw. After that, what did we see? We saw that a body of mass 1 kg kept on the surface of the Earth experiences a force which is equal to 9.81 Newton. Right? That also we saw. And then we started to discuss about only Earth. Now we will be discussing in this chapter only Earth. That Earth attracts every body towards itself by the same concept of universal force of gravitation. But since it is our darling Earth, we need to give it a new name to this force we call force of gravity. And the force of gravity will also have an acceleration acting on the body called acceleration due to gravity. Okay? Now, in that case, some concepts which you should happen. Think that this whole board is Earth, right? Some portion of Earth, right? Whenever you are solving such problems of gravitation, one thing in your mind should be this arrow. Come what happens, this is the direction of G, acceleration due to gravity. Always acting downwards, downwards, downwards. Whether a naughty boy or a girl has dropped something from her roof on balcony or a Chandrayaan has been launched, G is always acting downwards, downwards, with a value which is equal to 9.81 मीटर पर सेकेंड स्क्वायर. ये दिमाग में डाल लो, ये गलती नहीं कर सकते हो आप, राइट? लेट्स सी सम अदर थिंग्स. ओके, So one more thing we'll see. So now our expressions will all become clear from here. Okay, fine. That's it. It feels like as if you have put a sword inside. Okay. Now, this is the surface of Earth and also the x-axis of a Cartesian coordinate system. Imagine it in that way. This is your ground level. Ground level, and also keep the x-axis in mind. So this is y on the positive side, y on the negative. Okay, and here we are not worried about. You can just take it as x and x dash. That's the way you do. Okay, now we'll see that first of all we bring the concept of free fall. Only free fall. Free fall. And I'll write two lines. Agree with me if it is correct or not. In free fall, when you drop the body from the tower of a building, it's a displacement. Do you agree or not?
Yes.
That ball can't go this way, that way, otherwise. Ideal. Okay, there's no wind and anything. It's a displacement. Displacement means something called straight line motion. Agreed? And number two, this darling G gives it a scenario of uniform acceleration, right? Based on 1 and 2, I say that it is uniformly accelerated, that is with the value of G, uniformly accelerated motion in a straight line, and the straight line is nothing but the drop. Agreed? Which helps me to believe again that SUVAT is applicable. SUVAT is applicable. Have your concepts clear. We can apply SUVAT out here. Suppose a cobra snake is going this way, see, uniform acceleration, but like this. Can you apply SUVAT? No. It's not in straight line. Yes, it's not straight line. Acceleration may be same, but acceleration is not a straight line. Only SUVAT is applicable. Means chapter 1 haunts. It haunts you once again. Okay? And we'll see that. Let's see the equation. So, let's see the first equation. We'll see from chapter 1 perspective. Chapter 1. Chapter 1 was all about linear motion. Linear means our body was going either this side or this side, but now our body is coming down. Okay? Chapter 1, what was the first equation of motion?
V is equal to U plus 80.
V equal to U plus 80. Right? And here I will write gravitation. And I write this as free fall. And I will see how the expression changes in this case. How V equal to U plus 80 will change. Right? So you are dropping a ball from where? From here. Okay? Yeah, so let me make some things. I'm dropping the ball from here. So let's also see the displacement is towards this side, right? This is, and I won't call it S, I'll call it H because makes more sense as a height. This is a vertical displacement, so I call it H. Correct? Understood? So it's being dropped. First category, U is equal to 0. Do you agree? Right? G is acting in which direction? Downwards. In terms of Cartesian coordinate, which side?
Y-axis.
Which y-axis?
Negative.
You will never forget in your life if you do it well. Understood? Negative. We're going, acceleration is a vector. We have to give it a direction. This negative does not mean reducing, children. It's a vector, so we are giving it the direction. G is going downwards. Out here, it attains a final velocity v. Which direction?
Downwards.
Downwards. Negative. U is equal to 0. But if you observe this equation somewhere here, suppose you want to test what is the scenario happening here. The ball will also come to this place, right?
Yes.
And sometimes you might be interested in a problem from here to here rather than from top. At that portion, you will have a value.
Yes.
Which direction?
Downward, which is negative.
Negative. And what about the displacement?
Displacement,
Negative. You're coming down, right? So we merge this equation in terms of gravitation now. Negative v is equal to negative u, and I'm putting my equation from here, beta, not from here. I'm taking generic. If you want to say why sir you are not doing this, अरे इसमें जीरो बिठा देना भाई, हो गया तेरा काम, ठीक है? U plus a is my negative g. Agreed? And what about time?
Time is gone. Is there like no time given?
No, time we have to go. We are just transforming this equation to this category. Positive or negative?
Positive.
Yeah, time can never be negative. It's only for ghost, bhoot, pichas, this is negative, not for us. Time is always positive. So let's see the equation. Take the minus common out from here. It becomes v is equal to u plus gt. So the equation which is v equal to u plus at transforms to v equal to u plus gt for a free fall. This is your first expression.
same for the second and third.
Many children in school they may tell like this, since gravity is acting along with you, so this comes plus. ऐसा मत सोचो, गड़बड़ हो जाएगा. ऐसे करके सोचो, कभी भी fail नहीं होगा. गलत हो ही नहीं सकता. I explained you how to do the first equation. Now we'll do the second equation. Okay, you all will do more, I'll do less. Are you done with the first equation? Copy कर लो. So this is free fall. Hey, Neha Sanvi, understanding or flying overhead? Okay, very good. Till the time they write, I'll just write the next equation here. S equal to ut plus half at square. कुछ नहीं करना है, सिर्फ अपने को values डालना है. Instead of s, what is the parameter we are using? H. And what is h? Negative. Negative of h is equal to negative of u into t plus half negative of g into t square. Do you get it? All the negatives can be taken common from here. You take negative, negative, negative. So this equation transforms to h equal to ut plus half gt square. हाँ, लेकिन जब आप बॉल ऊपर फेंकोगे ना तब सारा साइन गड़बड़ हो जाएगा, देखते रहो, ठीक है? वो भी करके छोड़ेंगे. थर्ड इक्वेशन लिख लेता हूं मैं. ये ना इक्वेशन 1, linear motions, and also third was what? V square equal to u square plus 2as. 1 year is v square minus u square equal to 2as. Still correct, nothing wrong in that. ठीक है? चलो इस इक्वेशन को देखते हैं. Yes, Aparna, tell me. V is negative out here. So negative v square is equal to negative u square plus 2 into negative g into negative h. Negative of a square is always same as positive square. U square is u square plus 2gh. बस हो गया. क्या इतना रटना मारने का? हो गया तेरा इक्वेशन. And on these you will get numericals. This concludes your gravitation. Your gravitation is over today. After this is flotation. Flotation. Yeah, take the scale na. Why don't you ask from me? डरते क्यों हो? My flotation is a different chapter, not this. Gravitation is over. Flotation is a different chapter. Okay. Now, okay. Okay, I'm just shifting my x-axis here. Children, do you understand? Because I don't want to damage that part of the drawing. Imagine the x-axis, ground is now here. This is the ground, okay? And now we'll see free fall, you understood. Now our next case will be thrown upwards, thrown
Upwards.
vertically upwards, vertically upwards. Still qualifies for SUVET? Yes, why not? Thrown vertically upwards qualifies for SUVET. Straight जाएगा ऊपर. इसके लिए भी क्राइटेरियाज देख लो. Number 1, G will always be negative. ऐसे ही आ रहा है. G is negative 9.81 meter per second square. Now where is your ball? Out here. Where is it traveling to? Sir, upwards. Upwards. So what about the H? Positive. You threw it upwards. That means your U was also positive. And here when it reaches, at that case V will come 0, right? And when V becomes 0, this particular height is known as maximum height. This is maximum height. But we will not do our calculation till maximum height. We'll do our calculation till somewhere here, right? And we will call this as our H. H is positive, and here still my V will be positive, though V's value is reducing because V is going upwards. 3 parameters you need to remember. G always negative, ball thrown upwards, U positive, displacement upwards, and V it is getting into 0, but the value is still positive. Once it starts falling, then V is negative. And why is it getting to 0? और ये इसको oppose कर रहा है ना, retardation आ रहा है इसमें, इसलिए तो velocity घटता जा रहा है. So let's start again looking at these equation. चलो, number 1 equation is what? V equal to U plus AT. Let's transform that for thrown upwards. Who will help me to transform? V is positive,
Yeah.
U is positive,
And
G is negative, G always negative. So your equation becomes V equal to U minus GT. Many children remember gravity हमारे खिलाफ है ना, तो negative GT. Like that. Let's go to the second equation. S equal to UD plus half AD square. So here it becomes H. H is positive this time because एक बार देख लो, H is positive, we're going upwards. U is positive, T plus की जगह पे minus हो जाएगा, plus half negative G T square. So your equation is H is equal to UT minus half GT square. Understood? Second equation. All in exam you will have doubt is on the signs. अरे इसमें plus था कि उसमें minus था. और तीसरा क्या था? V square
minus U square.
is equal to U square plus 2AS. Convert it. Positive of V का square, positive H I should write, positive V, positive U all, is equal to positive U का square plus 2 negative G into positive H, which means your equation is V square equal to U square minus 2GH. Bas. Chapter over. Anything that is Greco-Latin or Azerbaijanian, you can ask me the question. I'll try to explain once again. That is not a worry. Sanvi, too much today, right? The man jokes every day and makes it easy. Why has he rushed so much today? Because he's going on a holiday in October and is already in his holiday mood.
So can you explain the last part, like so the graph part?
Throwing upwards?
Yeah.
Okay, now forget this much of the diagram is not there in the book itself, okay? Only see the bottom part. I've tried to. Now you are here. Ball is being thrown upwards. Velocity, positive y direction. Final velocity, positive y. Displacement, positive y. Gravity is always negative y. Agreed? Parameters have you understood, Neha? So now start putting your equation. First equation was V equal to U plus AT. So it becomes positive V equal to positive U plus negative G into T. So it becomes V equal to U minus GT. Second equation was S equal to UT plus half AD square. It transforms to positive H equal to positive UT plus half into negative G into T square. So it becomes H equal to UT minus half GT square. Got it? Third equation is V square equal to U square plus 2S. In this case, the v is positive upwards, the u is positive upwards, g is always negative, h is positive, so it becomes v square equal to u square minus 2j.
So basically, signs we have to take care of, and the A becomes.
And the very good thing here is, so let me write it with black pen, else it will not be visible for you out here. Remember this part. They will always say a ball thrown upwards reaches the maximum height, means in that problem v is equal to 0. At maximum height, at max height, v is equal to 0. ये कोई नया चीज थोड़ी है. क्रिकेट विकेट खेलते हो तो सोचो ना, when you hit a ball for a 6, the ball reaches the maximum height, velocity has to be 0. After that, velocity takes the negative course, it starts coming down. And why all it happened? Because the acceleration is always against you. It's a negative acceleration, which is retardation. So when I throw Sanvi upwards, she doesn't go with force, she will slow down as she is going up because she is retarding, and then reaches somewhere 0. Now she starts falling. Correct? Because when she is falling, G is supporting her. धड़ाम से गिरेगा इसलिए नीचे. So if this G was not there and I threw Sanvi, then Sanvi is in Neptune. चला गया, आएगा ही नहीं कभी.
Final velocity is.
Earth is not pulling. Earth's pull is what? Mass of Sanvi into G. G is 0. Sanvi may be whatever mass. Earth is not pulling. We don't want you. Go. So she's in Neptune now.
So at max height, the.
अरे मैक्स हाइट पे 0 नहीं होगा तो बॉल तेरे हाथ में वापस थोड़ी आएगा. तू रिवर्स कैसे करता है, जरा इधर सोचो, लीनियर सोच, लीनियर रिवर्स कैसे करता है? ऐसे सीधा जाके अचानक पीछे आ पाता है? एक बार रुकता है ना, कभी तो रुका है 1 सेकेंड, तभी ना पीछे आता है. बॉल भी तो वैसे ही ऊपर जाके रुकेगा फिर आएगा नीचे ना. The class